Hey guys, I just wanted to make a quick video to help you if you were getting stuck on any of the practice problems on the quiz. So I apologize that these aren't necessarily exactly in order because I was pulling pictures off your quiz, and anyway, the way that they came in, they're not quite in order, but I think this will help us out a little bit. So the first one says find the sine of negative 2 pi over 3, and actually let me pull in the unit circle. There's one. So if I look here, we want negative 2 pi over 3, right? So positive 2 pi over 3 is here. That's 120 degrees. So negative 2 pi over 3 would go, from 0 clockwise, and you're going to hit at 240 degrees, or 4 pi over 3. And so we wanted to find the sine of that. So sine is always the y value. So it'd be negative square root of 3 over 2. All right. So for that one, no calculation. You just had to find negative 2 pi over 3 on your unit circle. Let me get rid of the unit circle now, if I can. Delete. There we go. So that one would be negative square root of 3 over 2. All right. For the one of the second ones here, maybe number 3, I think this was, it says find the value of the indicated trig function. Give an exact answer with a rational denominator. So that means no square roots in my denominator. So they've given me a triangle where the sides are 6 and 7. So if I want to know the hypotenuse, I'm doing Pythagorean theorem, which gives me 85. So if c squared equals 85, then the hypotenuse is the square root of 85. All right. And now they want me to find sine, which is opposite over hypotenuse. Well, the opposite side from theta is 7, and the hypotenuse is 85, square root of 85. So we want 7 over the square root of 85. And then we want to rationalize that denominator by multiplying by square root of 85 over square root of 85. So we get 7 square roots of 85 over 85. All right. So B right there. So if I'm given a triangle, use Pythagorean theorem to find the third side, and then you just want to use your SOHCAHTOA. All right. For this next one, you want to use all the trig identities on that trig reference sheet that you have. So really go back to that every time you get stuck. They've given us sine and they've given us cosine, and they want us to find cotangent. So if you look at your trig identities there, cotangent is the cosine of theta over the sine of theta. So that would be 3 over 4 divided by negative square root of 7 over 4. And so if I multiply that, I get 3/4 times 4 over negative square root of 7. The 4's cancel out. And I get negative 3 over the square root of 7, which again, if we rationalize, is negative 3 square roots of 7 over 7. All right. So that one would be D. Similar idea here. They want me to find secant. So I'm going to use my trig identities. Secant is 1 over cosine. So here I'm going to do 1 over 1/3, because I know cosine is a third. And that would be the same thing as 3. Another trig identity here. These are your co-function identities. Well, sine and cosine are co-functions, so the cosine of theta has to be equal to the sine of 90 minus theta. So if I know the sine of 90 minus theta, then, if I know the cosine of theta, the sine of 90 minus theta has to be the same. So it would just be 3. And then the piece where we're getting into the quadrants. So the way I think about this one, cosecant is positive, is what they tell me. That means secant is 1 over sine. So sine has to be positive, and sine is the y value. So y has to be a positive. secant is also positive, which means 1 over cosine is positive, and cosine is the x. So x has to be positive. So the place where both the x and the y value are positive is in quadrant 1. And I think there's 2 more here. For this problem, negative 512 is the point, and we want to find the cosecant. So I'm going to take this and put it on a graph. So negative 5, positive 12 would be here. Connect that back to the x-axis. Now remember, a real angle is that, but I'm going to create a reference triangle by connecting it to the x-axis. So theta prime is my reference angle. I know the side lengths. Well, if this point is negative 5, 12. The x direction is negative 5. The y direction is 12. And using Pythagorean theorem, you're going to find that C is 13. Hypotenuse is always positive. So if I want to find cosecant, cosecant is the opposite of sine, so it's hypotenuse over opposite. So it would be 13/12. All right, so anytime you have a point, graph it, make a reference triangle. And then the last one I want to show you, there's a few of them that are using this idea of giving you a value and giving you the quadrant. Again, you're going to go to the graph, okay? So this one in particular is in quadrant 3, so I'm going to make my reference triangle in quadrant 3. Theta prime there. Cosecant, like we just said, here it's negative 7/4. That's hypotenuse over opposite. Just remember your hypotenuse is always positive. So that's a positive 7. Then opposite side must be a negative 4. And because we're in quadrant 3, we are going to have a negative x value here as well. Okay? Because in this quadrant, both x and y are negative. So use Pythagorean theorem to find b squared. So we get 49 minus 16, or 33. So b, this missing side here, is the square root of 33, and it's negative because we're in quadrant 3. So the quadrant gives you the negative positive signs. And then they just want us to find cotangent. So cotangent would be adjacent over opposite. In this case, negative square root of 33 over negative 4, which is positive square root of 33 over 4. It's okay to have the radical in the numerator, just not in the denominator. So I hope this helps with some of your quiz questions. Email me if you have any confusion or questions about this. All right.